So imagine this. It's Monday morning and you've just picked your coffee. You're walking into the office and it's gonna be a beautiful day. And then you see your boss walking down towards you and you already know that you're in trouble.
Mia, what the heck? I was checking the app yesterday. The startup time is super slow. It has so many errors. Like, sometimes I'm wondering, are you even testing your own code?
I don't know. I tested the app yesterday and everything went fine.
Oh gosh. Go and fix it, like now.
Sure. I will. Just give me a second.
So, anyone has ever been in a similar situation?
Okay, you see, I'm not alone. Don't worry, we'll show you how to fix such issues together. But first, let us introduce ourselves real quick. I'm Michał Chudziak, Director of Engineering at Callstack.
And I'm Gawrysiak, Head of Sales at Callstack. And we're here today to talk about RAM.
Shouldn't we wait to the after party?
Not that kind of RAM. The one we are talking about today is real user monitoring. And we will look at it from 3 perspectives. How to use it for performance optimization, to identify issues before we see them on the bottom line, and to build better software and improve your business metrics. So real user monitoring is a form of tracking users' interactions within an application. It helps you identify front-end performance issues, measure trends, and improve the overall customer experience.
Okay, we've heard about it before. Many companies that I worked with have monitoring solutions in place. So why do most products still have issues? And why do most companies have trouble converting data into meaningful insights?
So integrating a monitoring tool is quite straightforward and easy. And after it's done, many companies think that the job is done, checked. But it's far from being done. They rely on out-of-the-box features and often fail to customize them. And for them, real user monitoring doesn't really work. You need to understand the data and convert it into meaningful actions. And only then you will see results. And only then, real user monitoring can actually work for you.
Yeah, real user monitoring is usually implemented by embedding some small pieces of code which act as virtual recorders in your application. So actions made by users, such as clicking a button or navigating into a particular screen or making a purchase, they are all captured, combined with information about the user's environment, their device, etc. And then they are delivered into the remote server where they can be visualized and analyzed. But you have to remember that the data you gather will be only as usable as your ability to respond to it effectively. So taking an action is a key to benefit from it.
We now know what real user monitoring is. But why do we even care? So the ultimate goal of real user monitoring is to figure out 2 things, essentially. What's your end user experience with an app? And how can such data be turned into meaningful actions? And in terms of how to do it, there are a number of existing solutions that you can use right away. Or you can build something on your own. But remember, as we mentioned at the beginning, tooling is really secondary. The key thing is to understand the data and implement processes around it so you actually use it.
All right, so it's time to get our hands dirty and fix some issues together. We are about to introduce you to the ways to use real user monitoring, and we're gonna start with performance optimization. So you can imagine that we've received this video to investigate the case. Have you noticed how slow the app starts? It's surely far from perfect. And at the same time, we have Instabug integrated into our project, and the metrics reported to the dashboard seem fine. So no alerts, no regressions, but the app still performs poorly. So what the heck is going on? And we'll begin with understanding the case. It is a key to optimizing essentially anything. So majority of the problems that might seem hard at the first glance often have pretty straightforward solutions.
And this time is no different. So let's zoom into the app launch metrics from Instaback. How should we interpret them? If we analyze the path the user takes, we will discover that it's not always the same. And that's quite common for most mobile apps. Users who are logged into the app have a different startup experience than those who are not logged in. So we need to map all potential landing screens for the app and prepare separate metrics for these cases. You can notice that in our case, reaching the feed screen takes much longer than accessing the login screen. And furthermore, the experience changes slightly depending on the platform. And we could analyze the device breakdown further, but that's not really relevant in our case, as you can see that both iOS and Android users are affected. So we need to look at our problems for a bit different angle to solve it.
And with that in mind, we'll change the perspective, but not the method. Breaking things down into smaller pieces is an extremely effective method of performance optimization. So we'll split the metrics into smaller chunks and try to find the problematic areas. Ready?
Let's get to it.
Yeah, every startup process in React Native consists of a couple of universal steps that happen before we enter the JS realm. The first thing that happens is the creation of the native process that will handle the app's creation and manage its lifecycle. Then we create an actual application, prepare everything that's necessary to render a UI, and execute our custom initialization code. Next, we load JavaScript and evaluate it. And this is the moment when your root index.js file is executed and the bridge is set up. Finally, we render native root views and the first React components come into play. Fortunately, measuring these phases is not the toughest challenge. React Native Core emits some useful markers, and the missing ones can be integrated using some native platform APIs. There's also a great thin JavaScript library that you can integrate into your app and reduce the need of touching the native code. All right, we've covered the native part, so let's focus on the JavaScript stuff now. It's a slightly different task as the phases will be usually unique to your application. And in our case, we did a couple of fetches, file system reads, and some rendering. Next up, let's set these markers in our code. The library that I've mentioned a moment ago supports setting custom JS markers, but you can also use any monitoring tools directly or implement them in your own way. So we've set up the infrastructure and started gathering the first results from production. And after a while, you will notice that some values do not make much sense. For example, there are startups that take for over an hour.
And nobody wants to wait for over an hour for an app to start, right?
Right. And that's why we need to fix these outliers. But first, we need to make sure that we do not compare apples to oranges. The application startup resembles a thermometer scale, rather a fixed set of states. And this means that we need to find a point on the scale that will be comparable between runs. And since it's hard to measure the exact temperature, we can look at the edges of the spectrum. So fully cold and hot starts. And we'll focus at the cold ones because otherwise we'd be essentially looking at the app changing state from background to foreground.
Another perspective to consider is the type of process that starts the app.
Yeah, the most common scenario is starting an app in the foreground. So we click an app icon and the app starts. And in that case, it has the priority in getting all of the required resources. However, there are multiple cases, multiple scenarios when your app can be started in the background. For example, if you have integrations like HealthKit on iOS, or if OS tries to anticipate your behavior and pre-warm the app for you. And in that case, priority for resources might be a bit lower. And finally, your app might be started by a user in the foreground, but then put into background. And this is also a different case.
Having that said, we'll consider only the cases from the first scenario, as there we can reliably compare the results. And now that we've got the full picture, we can implement the required changes in our app. And we have prepared some code snippets for you to catch the outliers. Some of them require native changes, but even if you use Expo, thanks to the pre-built functionality, you can easily plug into those native hooks. So feel free to scan the QR code visible on the screen. We've prepared all the snippets and all the links to the materials explaining our code in details. And if you would like to learn more about React Native performance optimization, we recommend visiting our blog for more expert materials.
Okay, so that's enough theory. We can get back to our case. As you can see, we have implemented all the detailed metrics and started getting the first results. And there are a couple of bottlenecks in our process. So a few metrics take unusually long time compared to the standard React Native apps. For example, fetching the feed data consumes most of the time. And there's also something suspicious in the native app creation, which takes almost a second. Subsequently, session restoration, which should be a fairly simple process, takes over a second. And after defining these problematic areas, we can start thinking about the solutions for these problems. In our case, we could lazy load some SDKs, replace the file system interface with a more efficient one, or implement some caching or parallelize the requests. So voila, with a few simple tricks, we have halved the length of the startup process for logged-in users.
So before we move on, let's sum up things real quick. Firstly, we understood the problem. Then we broke it down into smaller pieces, and we applied laser-focused optimizations. We can observe that the app works faster for logged-in users. What's even better, some of our optimizations have positively affected other scenarios. So we've just discussed how real user monitoring helps with performance optimization. Another area that we can use it for is problem discovery. And when done right, this can be even more powerful than performance monitoring. If you move fast and ship stuff frequently, there is a high chance you break things. The user experience for the same product may vary for end users. In our case, the second user with different app version and with different device experiences slower load times for certain screens. There are multiple errors when trying to proceed with the purchase. And finally, they can't make a purchase because the button for finalizing the payment is way off the screen and not visible for user. That's not great for business.
Yeah, it surely isn't. That's why we'll zoom into the screen load times first. And thanks to the amazing library from Shopify, we can accurately measure how long it takes for the user to wait until the screen becomes fully interactive. And as we can see on the chart, there has been a regression in the recent version, driving the load times for the product details screen up.
That's not great, but at least we know where to look. And we can analyze the changes between the last two versions and try to find problematic commit. In our case, it was just silly refactor. Well done, Michał.
It happens. So next, let's look at the errors. Most real user monitoring tools provide excellent analytics and debugging tools for errors and app crashes. And in our case, the issue was related to some malformed API response. So except for better error handling, there's not much more we can do on the app side. However, we can assess the extent of an issue and understand its impact on the user experience. And real user monitoring can help with that. especially if we attach some additional data such as counters or breadcrumbs to fully understand the experience.
And now we can use the gathered data to help business set priorities for fixing certain problems by engineering teams.
Okay, but what do we do about the missing button? This is not an error or a performance issue. It's probably just some broken styles.
So how did we miss that in the QA process?
Oh, here we go again. I don't know, but there's something we can do to see the symptoms of such problems in production. And this is where monitoring user interactions come in handy. We can observe trends in user behavior by constructing funnels for critical user interactions. And in our case, it's the purchase flow. So if we look closely at the conversion rate, we can notice an anomaly in the recent version. So let's apply some filters to understand the nature of the issue better. Looking at the platform breakdown, it seems that the drop has happened specifically on Android. And that's concerning. And we can play with filters even more and notice that certain devices are affected.
So this release is surely unhealthy.
Yeah, that's true, and we need to hold it. And using the similar change analysis technique, we can pinpoint the problematic change and fix the code. And as you can see, with some rollbacks and bug fixes, we managed to fix the issues that arose with the recent update. And UX is now consistent across the platforms, and the app is pleasant to use again.
Great, you fixed the issues, but I had to tell you about them in the first place. So what if I hadn't looked at the app yesterday?
Yeah, that's a great question. There's surely something we can do about it. As we have key flows, UX requirements, and metrics defined, we can set up production alerts really easy. And most of the tools offer integrations with Slack or Teams or any other communication tools, and all of them can send you an email in case something goes wrong.
And that was just an example of powerful and impactful things we could do with the data. We often associate data engineering only with teams of analysts. But in today's world, perspectives of data and software engineering infiltrate each other.
And that's why we want to encourage all of you, developers, to explore the world of data, because code is data and data is code. So play with it, construct your queries, and understand the impact of your work on the end user.
Okay, so we've talked about performance optimization and issue resolution, but real user monitoring is more than that. It can also be used to improve your business metrics. Organizations need modern monitoring solutions that acknowledge the link between performance, user experience, and business objectives. And there are many ways to leverage the data collected from end users. So let's look into examples of improvements influenced by real user monitoring that have a direct impact on your business. And one of the most important metrics for business is conversion rate, the percentage of the end users that took as a desired action in your app. And the importance of conversion rates lies in how it reflects the overall effectiveness of your app, as well as the product and marketing strategies behind it. So the higher your mobile app conversion rate is, the more successful your app is likely to be. Let's look into the app purchase conversion rate throughout the app events channel. In the current user flow, we start the app, go to product details, basket, checkout page, and then we proceed to payment. Isn't it a lot to just buy a shampoo? So we set up a hypothesis. Reducing the number of steps in checkout flow will increase number of purchases. Now our user doesn't need to go to basket to make a purchase. They can click Buy Now button straight from the product detail page. So we can test our hypothesis, see results, and then, based on real data, make decision which flow to keep. How do we do that? For example, by performing A/B testing. Essentially, it eliminates all the guesswork and enables us to make backed by data decisions. Hypothesis confirmed. in our case, conversion rate was increased from 1.4 to 2.8%.
Yeah, so real user monitoring is a great way to evaluate the success of a new feature or a change from both technical and business perspective. If you combine it with A/B testing, you will get an exceptional tool for analyzing the results of improvements. And it will also help you choose optimal variants for your performance or user experience.
And when we talk about user experience, let's look at user journey as a whole. Understanding the app user journey is like reading a map, illustrating where user starts, the paths they went through, and seeing their final destination. And an optimized app user journey is essential. By understanding it and making improvements based on your users' behavior and their feedback, you can significantly increase user retention and drive your product success. So, retrace the steps of the actual users of your application to understand what screens and paths they went, so you can gain visibility into each stage of the customer journey. Of course, keeping user privacy in mind. Mapping out the most common roads that led to some actions helps you spot issues and areas for improvement that have a direct impact on your business metrics. This data also can help business teams make informed decisions about where to focus further optimization efforts. So let's dive deeper into the most critical stage of user journey, retention. App churn rates represent the percentage of users who uninstall or stop engaging with your app over a specific period of time. And churn rate directly impacts your app revenue. The higher the churn rate is, the fewer users you have to monetize in your app through app purchases, subscriptions, etc.
So keep in mind that you as a developer have a direct impact on such things.
And if you want to stop losing users, you will have to discover and analyze why they're abandoning your app in the first place. So take note of popular exit paths to get an idea of the screens and that user visited before uninstalling your app. And once you have that knowledge, you can take steps needed to address your user issues to improve their experience. And if you send out any service asking users directly why they left your app, just make sure to analyze what they said and verify that information against the user paths and take into consideration the user-specific environment. As we know, what customer says is their reason to churn may technically mean something completely different. We now know how to use real user monitoring in practice and make informed decisions based on real data. So how about we go back to the beginning to see if there's a different possible ending to our story. But for that, let me put once again my boss hat. Michał, what the heck? I was checking the app yesterday. The startup time is super slow. It has so many errors. I don't know where to even start. Sometimes I'm wondering, are you even testing your own code?
Hold on, there's been an issue and it was identified a few hours ago and our engineering team is already on it. So the fix will be shipped within an hour.
Okay, Michał, you called me down. You're keeping your job this time.
Nice. So today we've talked about real user monitoring, what it is, why it is important, and how to use it. And additionally, we looked into it from 3 different perspectives: performance optimization, problem discovery, and business insights.
So we want to leave you with a few thoughts. Collecting data is really the first step to effective real user monitoring, but you can't stop on that. To make an impact, you need to learn how to analyze it and take action.
Yeah, the experience of an end user might be completely different from what you experience on your device. And real user monitoring helps with understanding the full picture.
Finally, real user monitoring helps both engineering and business teams make informed, data-driven decisions that have a direct impact on your business objectives.
Yeah, and that would be all from us. Thank you all.
Thank you.